and this is the solution to question 5 of the practice SAC for the upcoming SAC on organic chemistry and covalent bonding and intermolecular forces. I am going to finish this one of these days. This is the third night I've started filming, so hopefully today is the last. We'll see. Now, this question asks you to provide balanced chemical equations, and you don't need to include states. This is an issue that's going to come up later, hopefully at the start of the next unit and definitely next year. So right now, we don't have to worry too much about it. The first equation is complete combustion of octane, and you need to use molecular formula. Now, molecular formula just show the number of atoms of each element in the molecule. It doesn't give you any information about the actual bonding. So in the case of octane, now you can draw the molecule out and count the number of carbon and hydrogen atoms, or if you just remember that octane is an example of an alkane, which has the molecular formula, the general form, which is 2CnH2n plus 2, for n being the number of carbon. So if something is named octane, then the number of carbon will be 8, because the name always gives you the number of the longest carbon chain. In that case, the molecular for octane will be, the molecular formula is C8H18. So that's a quick way to work out the molecular formula without having to draw the molecule out. I mean, you really want to save time as much as possible. What if I give you datocane? You don't want to draw 10 carbon and 22 hydrogen atoms, and if you count them wrong, it will stuff up your equation still. Alright, so complete combustion means that this is a reaction with oxygen, and when you burn a hydrocarbon, the products would be CO2. I knew it was going to do this at one point. I just never knew when. Why does it do this though? Okay, let's go down to my question. And we're back. So produce CO2 and H2O. Okay. Now, when you balance combustion equations, the way that I tend to do it is I always start with balancing the C. So you have 8 carbon on the left. I need to put 8 here in front of carbon dioxide so that the carbon is balanced. The next element that I will balance will be the hydrogen. Now, the main reason why I usually leave the oxygen to the end is because you have this O2 molecule, so you can't really change the number of oxygen on the left side without interfering with any other element. So in order to balance the hydrogen, there are 18 hydrogen here, so I need 9 in front of H2O to give you a total of 18. Now, once the carbon and hydrogen have been balanced, we can see that we have 16 oxygen on from CO2, so you have 8, and you need to multiply it by 2 because you have 2 oxygen atoms per CO2 molecule, and you also have 9 oxygen atoms from H2O, which means that you have 25 oxygen atoms overall on the product side. So I need to get 25 oxygen atoms from the reactant side to balance that. And in order to achieve that, I'm just going to need to put a 25/2 coefficient in front of O2. So if you have 25/2 multiplied by 2, you will also get 25 oxygen on the reactant side. You obviously don't need any of this extra working out. You only need the equation in the box. But this is just mainly for you to understand where the numbers come from. So that's A. Now part B asks substitution of methane with bromine using structural formulas. So structural formulas mean that you need to show all covalent bonds. You don't need to show any lone pairs. It would be nice to have the shape, but I think it's okay. And well, you don't necessarily have to show the shape for structural formula. I'm going to react it with Br. And because this is a substitution, you only need to write the very first product that can be substituted. And in the case of methane, one of the carbon-hydrogen bond will be broken and the Br bond will be broken. And you probably don't want to, all right, that was not a good decision. Let's try that again. You probably don't want to draw these extra lines on the covalent bond. So I'm going to redraw my hydrogen and my bromine. Okay, so you're replacing one of the hydrogen atom with the bromine, and you end up with the three hydrogens still there, and the other product will be HBr. So that's that. That's good. The next question is condensation reaction to produce propylmethanoate. Use structural formulas and concentrated concentrated sulfuric acid as the catalyst. So if this is an ester, because it has the suffix oate, so propylmethanoate. Now, there are multiple ways to draw an ester, and at the end of the day, you decide on the best method. But what I tend to do is I start with, am I going to have enough room? Probably not. Okay. I start with the ester bond. Okay. And this is actually very unusual of me. I tend to go CO, double bond O, and with the single O on the right side. But let's do it this way, which actually matches the name a little bit more. So you have this side of the carbon, which is linked to the single bond oxygen. This is the alcohol side. Let's just get a little bit more room. Okay, so this is the alcohol side, and there are 3 carbon atoms in the alcohol according to the name propyl. So I need to draw 3 carbon here. Now what I am doing is I'm drawing the product first. You definitely can just start with the reactants, and that's okay. But if you're not sure, then it's probably a good idea to just start by drawing out the ester, and hopefully it will be a little bit clearer as in what the alcohol in the carboxylic acid has to look like. Now this is where people tend to make a mistake. You have a meth in the carboxylic acid, and you have to count the carbon that is linked to the double bond O as part of the longest chain in the carboxylic acid. So if there's already 1 carbon here, except for the weird wiggle that I just put in. If there's already 1 carbon here, and the name only has 1 carbon, you actually don't need to add any other carbon atoms to the acid structure, and you can just finish with a hydrogen. So this is propylmethanoate. The other product of the condensation reaction has to be H2O. So I'm going to draw it there before I forget. And now you just need to draw the 2 reactants. So the original alcohol will be propanol. Well, propane 1O is more accurate. Obviously, the OH has to be on carbon 1 in order for it to create a propyl as in the ester. And the other reactant is methanoic acid, which actually only has 1 carbon in it. And that's it for part C. Now I'm going to write concentrated sulfuric acid here just because, you know, the question specifically tells you it is concentrated. Now you probably don't know what AQ is yet. You can just write concentrated like the word H2SO4, and that's okay too. Okay, and then we have another one. We have part D, hydrogenation of pen-2-ene. Hydrogenation, that is not a good sign. Okay, that's fine. Hydrogenation is just a fancy way of saying addition reaction or reaction in general with H2. Whenever I hear the word hydrogenation, I do imagine an army of hydrogen for some reason. So addition reaction, now the reason why I say addition is because we're talking about an alkene here, and alkene undergoes addition reactions. So pen-2-ene, once again, you need to use structural formula according to the question. Now, the way that I tend to draw alkanes, or well, the way that I tend to draw organic molecules from their names is I always start with the longest carbon chain based on the question. So question say pent, I will draw out 5 carbon in a chain. And it also tells you that you have a double bond at the second carbon. So when the question say the double bond is at the second carbon, it means it's going to be between the second and the third carbon, because you always indicate, it's going to disappear in a second. Yeah. Okay. It always indicates the position of the closest carbon, the carbon closest to the end. And that's that. And now I'm going to finish with hydrogen. That's not a very good covalent bond. Let's try that again. All right, now you want to be very careful around this C, because you want to make sure that each carbon only has 4 covalent bonds around it and not more than 4. Okay, so that's pen-2-ene, and it's going to be reacting with hydrogen gas, which is H2, not H. And because this is an addition reaction, what will happen is one of these bonds in the CC double bond will break, which create 2 possible openings, so that 2 atoms can be, or group of atoms, can be added to the molecule. And in this case, one of the hydrogen is going to be added to this carbon, and the other hydrogen will be added to the other carbon. So I will end up with this, and then I have 1, 2, 3. So you need to break the double bond, obviously. I think you just end up with a pen-10, which is not very exciting. But, you know, what can we do? Things are added together. This is actually the way to make an alkane from an alkene. If you want to make more petrol, we'll talk about that later. All right, that's it for question 5.